Hello everyone. It's our pleasure to share our solutions in the VizWiz-VQA challenge this year. I would like to give a video recorded presentation of our work in VizWiz-VQA. From left to right, our team members are Ringang Li, Yaqian Zhao, Hongwei Kan, Zhenhua Guo, Baoyu Fan, Runs Zhang and Xiaochuan Li, respectively. I will introduce our work from the following aspects. VizWiz-VQA stands for a dataset including photos taken by blind persons with 1 recorded spoken question and 10 crowdsourced. 2 containing tasks of VizWiz are proposed. Predict the answer to a vision question, and predict whether the visual question cannot be answered. Compared to the deprecated version as the 31st of December 2019, the new version dataset contains more train validation images with local obfuscation which avoid privacy disclosure. The overall solution can be divided into the following parts. Firstly, we try to employ the blip model to obtain the preliminary VQA result. Secondly, we trained the MDETR model to get the segmentation mask given the question and the image. Thirdly, we generated the OCR texts of the segmented image if the image contained the OCR. Finally, we added the OCR texts to the question and retrained the blip model. The second phase optimization can largely boost the OCR answer, especially the number questions. For the first stage, we mainly employed the blip model for the VQA baseline. The blip put forward the multimodal mixture of encoder-decoder and processed the ITC task, ITM task as well as LM task. ITC task means to align the feature space of the visual transformer and the text transformer by encouraging positive image text pairs to have similar representations in contrast to the negative pairs. ITM task aims to learn image text multimodal representation that captures the fine-grained alignment between vision and language. LM aims to generate textual descriptions given an image. From my point of view, LM task is the most important because it transformed the discriminant task into the generative task, especially in downstream VQA task. Blip considers it as an answer generation. During the finituning, the image question is first encoded into multimodal embeddings and then given to an answer decoder. We made such modification compared the original blip experiments. Firstly, we enlarged the image size from 224 to 384 in the pre-training phase and the image size from 384 to 480 in the finituning phase. Secondly, we changed the text encoder from BERT base to BERT large. After we pre-trained the blip according to the blip paper configuration, we finituned the VizWiz-VQA dataset. We took a 2-step training finituning strategy. Firstly, we finituned the VQA task with the VQA, GQA, visual genome, text VQA as well as the VizWiz-VQA datasets. Then we finituned the final model with the VizWiz-VQA datasets. After the first stage VQA task, we obtained the 66.34 result with the multi-model fusion. For the second stage, we firstly trained the MDETR model. We collected all of the text-guided datasets for the MDETR model, including phrase cut, ref COCO series, greph as well as VizWiz answer grounding. As the picture shows, the segmentation area for the evidence to the answer is generated. Then we generated the OCR texts from the segmented image if it contains the OCR information. Finally, we retrained the blip model by adding the OCR texts to the question. This second optimization largely increased the number question accuracy. Through the challenge, we summed up the relevant tricks for our VizWiz-VQA challenge. Firstly, VizWiz-VQA dataset contained limited data size compared to the pre-training phase data, so the midterm finituning in a larger downstream dataset like VQA, GQA can help better reduce the dataset gap. Secondly, we tried the blip model for its flexible encoder-decoder model. The LM generative methods seem to more reasonable in reality. Finally, answer grounding result can sometimes serve for the VQA model especially in the OCR cases. Thanks for watching the video.